Hi guys! So, today I'm going to be telling you a little bit about adding and subtracting rational expressions, which is from the second lesson that we learned in math. So, let's start off with the word LCM, which you might have seen mentioned quite frequently in our lesson. So, L stands for least, C stands for common, and M just stands for multiple. It might look a little more terrifying than it actually is. It's just a simple way to put the technique that we're going to use in solving and simplifying expressions. So let's start out with an example. X plus 1 over x minus 1 plus minus 2 over x squared minus x. Okay, so let's take a look at this expression. The first section of the expression already looks pretty simplified, so we're going to leave it as is. Moving on to the second expression, it's looking a little needs simplification. So we're going to rewrite the first part of the expression. You can do this with me if you want to try it out yourself, or pause the video and solve as needed. Moving on. So we get to this bottom part of the second expression, x2 minus x. So what do these two have in common? They're both x's. So we can take out an x. Inside we'll be left with x minus 1, right? Distributive property. So LCM, using this concept that we just learned, we want the least common multiple. So what do you need to multiply this first expression by to give you this expression? What's missing? You're going to think of the missing factors. You're trying to get the smallest number possible, or smallest number or variable. So looking at them, they look the same pretty much, except this one has an extra x over here. So if we want to find out our LCD, our least common denominator, it's looking like x into x minus 1. That's it. That's the least common denominator. So in order to do this, we're going to need to multiply both of these by x up and x down, so it's equal. And we will have x squared plus x over, and we can make this a long bar because these two are essentially the same now. So we can put them over one common long bar, minus 2 over x into x minus 1. So you don't really want to FOIL on the denominator. You just want to leave it simple. You want to leave it factored. You want to leave it easy because you want to see if you can cancel anything out in the end. So if we want to factor this top expression over here, we can do some magic x. We can also do the quadratic formula. You can even use polysim on your calculators to make your life easier. But in my opinion, magic x and mentally factoring is the easiest. So we're just going to go for a x, two numbers that add up to minus 2, that multiply to minus 2 and add up to positive 1, which are going to be x plus 2 and x minus 1. And you put that over our common denominator, which was x into x minus 1. And we're already seeing patterns. Because we simplified it and because it's in factored form, you can cross these two out because they are the same. It is over multiplication, not addition. You cannot cross out over addition, only multiplication. And we're going to move on to have our final answer going to be x plus 2 over x. And no, you might be thinking you can cross out these two x's, but no, you cannot. Remember, it's only over multiplication that you can do that. So this will be our final answer, but hold on, don't exit the video yet. We're not done. We still have to set restrictions. Restrictions are very important in the world of algebra. And they are what make this expression not undefinable. If the denominator is 0, the expression and the answer will be undefined. So we need to do everything we can to avoid this denominator from being 0. So in order to do that, we look at the denominator, most likely the LCD, because that's what both denominators are going to be. And we look at them in factored form. So x, for this, according to the 0 property rule, this cannot be 0, and also this cannot be 0. So when you multiply this by to get this and get it to 0, so x cannot be 0, and x cannot be positive 1 as well. So that's it for today. Thank you for watching. I hope this helped you, and comment down below what you want me to explain next.